Alright everybody, welcome back. This is day number 2 of the Unix operating systems course, and yesterday we ended by I was talking about shell scripts and shell features and all sorts of different things. So today we're going to start out by looking at the C shell, and this is lecture number 7 for those of you who are keeping track of the lecture numbers. And it says Advanced Unix on it because it's actually something that only people who have taken a class in Unix will actually start doing or looking at, only because your average user is probably just going to install it and download programs and run programs in there. They're probably not going to do very much shell scripting. So there's this really nice shell called the C shell. Like on the beach, you got seashells. Actually, this is like C programming, and it offers you C programming in a shell environment, and it's one of the most popular shells that are on the market, so I thought maybe talk about it. But it also is an opportunity to talk about shell scripting at the same time, in a language that most of you are familiar with, which is C. So objectives of this lecture is to introduce the C shell, concentrate on the features, not in Bourne, which is the most popular user-level shell, not scripting shell. But many are in Bash. So we have Bourne, Bash, and C shell. So it's not all about C shell. I'm going to compare it with Bourne and Bash and a bunch of other shells that are out there as well. So this is your scripting slash shell. If I say that 100 times, I might actually say it clearly. Lecture. So here's the background. So originally part of Berkeley Unix, because Berkeley was probably one of the earliest versions of Unix that were out, and all those people at Berkeley, or all the C, the C godfathers of C who wrote C, came out of Berkeley. So naturally, the C shell is going to be their product. It's more tolerant of mistakes than Bourne and some of the other ones, and you can avoid accidental logouts and overwrites and all sorts of things because there's a lot of error messaging and control that's built into the shell environment. It's easier to configure, has aliases, history, job control, control over processes. As we saw yesterday, processes are sort of a core concept for Unix. Some scripting improvements over Bourne, but better variables, arrays, and expressions. So we'll be talking about that today as well. Almost all good ideas from the C shell have been added to Bash. If you load up your terminal prompt, you will probably get a Bash shell on practically every Unix build that you work on. So it's like the de facto standard these days. In fact, you just type in, actually look at your environment variables and you'll see what shell you're actually, because the environment variable is called shell, and you'll see what shell you're using. It's not all the same, but Bash, in fact, if you're on a MacBook, it's Bash. It's going to be a Bash shell. And most of all of the C shell features have been added to it. And as I was saying yesterday, most shells are pretty much equivalent these days because everybody borrowed and stole from everybody else. It's kind of like every word processor has the same features. Every shell's got the same feature. History, aliases, job control, directory stacks, all sorts of different things. So entering and leaving the C shell, check your default shell with PS. In fact, it's not a bad idea. In fact, I can probably bring up the terminal window. Hold on one second. Let me load the terminal window. It's only on slide number 4, so I'm not too far ahead of the game here. If I open up a terminal window, here we go. This is my terminal window. And, oops, no, that's not going to work. PS is going to show me my shell. And I see my shell is Bash, because PS actually from yesterday gives me, I have another shell that actually has a command called shell that I added in. There's a script. It just goes through and shows me a bunch of stuff about the shell. And I've noticed I don't have it loaded on this computer. But you can create your own commands and add them to the shell, and or your own scripts, which is why people do this. And then you open up the terminal prompt, you go to the shell, and you can run your programs, and it's kind of a way of customizing your user experience. As an example, I have one for the emulator that I run on here, and well, now it's going to say it's a shell script that I created. It's called emulator. When I ran it, it's tried to connect, but I don't have my emulator loaded, so it's not going to connect, obviously. Type in clear to clear your screen, but if I type in PS, I get a list of the processes that are running on this computer. And right now, the processes, the only thing that I have open is a shell, and the shell is basically, the command was Bash. So if I typed in Bash, I'm going to get another I'm going to get another shell, and that shell is loaded on top of the previous shell. If I typed in C shell, which isn't there, if I type in, no, it depends on what shells are installed on this computer. I think Bash is probably the only one that's on there. No, actually I got C shell as a, again, I've got a different prompt that showed up that looks like that. C shell command from, because my problem is I've made so many different aliases. I don't know which shell the aliases belong to. I originally tried to type in C shell, but on this one, the default name for the C shell is CSH, and SH is another form of a shell, which is another generic shell. So right now, if I type in PS, you see all these shells loaded. And what I've done here in the last couple minutes while I was talking to you is I just loaded up a bunch of shells. In fact, I loaded up three of them right here. Then these three sub-shells are loaded inside of the main shell. So if I start exiting out, I can go exit, exit, exit. Let's see where I am now. I'm back to the regular shell. All of the shells that you're loading up from a shell create sub-shells. And that was the last slide, actually, I didn't cover yesterday because I really kind of just wanted to do this for drill with you just to kind of demonstrate it to you. But the concept being it's layered. And so some shells have features that automatically exit when you open up another shell to conserve resources. Some of them have different commands, give you different environment spaces. If you do print env, you'll see all of the environment variables that are set for the shell when you go into the shell. And they might be a little bit different between the different versions of the shells, long story short. So it's a utility that's set that will hopefully allow you to customize your user experience in your environment. In fact, here's that shell variable that I was talking about before. My login script for this computer has my shell set to bin bash, which means every time I go to the terminal window, which is what I'm using right now, you can see it on the top of the screen, I'm going to go to this shell. If you're in a DOS machine, you're not going to get this because you're going to go to a DOS prompt. It's going to be a DOS window. You're not going to get to a terminal prompt. You're not going to be able to run any of these shells. So this is truly a Linux Unix environment. I can do this on a MacBook because, well, this is run BSD Linux. So, all right, so let me get back to the slide. I'm going to leave that shell open in the background because I believe I can, yep, there we go. I can go to it and then go back to it. So go back to PowerPoint, there we go. All right, so now I'm set up at least. So entering and leaving the C shell. You can check your default shell by typing in PS like I just did a few minutes ago. You can change the shell, and this particular case, you could type in C shell, or you can just type in this command here, change shell. Change shell unloads the first shell, loads the second shell. Typing in the name of the shell just loads the shell on top of the shell. So now you got multiple shells going on. And why do you want to do that? Well, it kind of conserves resources if you're changing it. You don't need that previous shell. Depends upon how many simultaneous users you have working on that system as to whether or not you're going to want to do that. That's not really that important though. C shell is actually TC shell on most Linux systems. So the C shell that I'm referring to here might actually be a TC shell, which is a smaller, slightly different version, more upgraded C shell on some systems. You can exit by typing in exit, log out, control D, maybe. Depends on the implementation. Depends on the system that you're on. One of the best parts about the shell is the history. And actually, I sort of demoed that to you a few minutes ago by using the arrow keys, and I'll go back and I'll show that to you in a few minutes. But you can get a list of the recently used commands or events, and you can reuse them. So set history is equal to 25. It's going to record 25 events. Set save history to 20. Remembers 20 events after you log out, so it keeps it in a file that's persistent. To see the history list, well, you type in history. So if I typed in history, I see my history. You can see I'm doing a lot of Android development right now. So you can see I've been running a lot of commands. Another thing that is built into the bash shell, and you can see bash on the top here. And the resolution is set kind of low, but it's not really a graphical user interface, so I don't really have to worry about it. It's those nice little up arrows. That's my cheat sheet, actually. I like using the up arrows. In fact, you can use the up arrows, and then you can backspace through the up arrows, and type some stuff in there, and then press return. Well, that stuff is it's not really a command. It's going to say command not found in this case, but then you can come back in and change it. So let's say you're copying stuff from one directory to another directory, or here I was uninstalling something in this particular case. Depends on what you're doing, what you're trying to accomplish, as to what you're going to use the history for, but it basically saves you from having to retype commands in over and over and over again. So if you're working in this environment a lot, like I am actually, I write scripts and just save them. And so my emulator one sets my environment for me. I've got ones to configure my system a little bit differently, to turn some services off, turn some services on, depending upon what I'm using this computer for. So I can sort of be a little creative in terms of how I'm using my shell environment. And so I don't actually save my history. I don't really like to, but you could do that. And then after you log out, especially if you're working on a terminal or a remote system, you can save the history, come back in, load the history, and then you don't have to worry about repeating commands. So in terms of using the history file, I showed you my technique. I like to use the arrows and go through the history that's saved in the temp memory. However, you can execute the last event by typing, and then this is the prompt here, so don't type in a $sign. This is actually called a bang bang. You type in the exclamation point, and it reruns the last event, the last thing. Or you can pick one and say, bang 3, and execute event number 3 in the history file. Or you can execute the most recent command that starts with some text, which is kind of like a wild card. Bang /emulator or something, would run my emulator command. So gcc loc is going to run the last gcc command that you ran. So it's kind of a shortcut way of running commands without having to remember them. Because the problem with the shells in general is they're command line interfaces. You got to memorize a bunch of commands if you're going to use them. Who sits around and memorizes a bunch of commands, and who likes to type them in over and over again? Nobody does. So you set up the environment to take advantage of the features that are available. The history is one of them. So in terms of the bash history with a number lists the last number commands that are there. So bash supports the same history list feature as most of the other shells do. So you can type in the bang bang, the exclamation point, the number, the exclamation point, and the text. You can also look at relevant environment variables that are associated with it. In fact, I don't believe I have a history set on my environment, but if I wanted to, I can take a look by typing in print env, or using the bang bang here, bring up the, there was the command I typed in a few minutes ago failed, so it's no need to run that one again. So if I typed in print env, and look to see if I had history in here, I don't think I have history set, and I don't really have history set because I don't really use that feature. The more you load in your environment variables, the more memory it's taking up, actually. It's kind of like when you load a bunch of stuff in memory. So I'm kind of a minimalist, and I've sort of stripped this out a little bit for myself, so I don't really keep track of history. Plus, it's also kind of a security thing. If someone got a hold of my computer and started playing with the history of my shell environment, they might mess something up on my computer or something. So, kind of a safety thing as well. But if your shell is keeping history, you can look at it through the environment variables that are set, and here's are some of the parameters that are associated with it. In bash, you can modify the prompt, including the history number, and it's inside of .bashrc, which is a file that's loaded in one of your configuration directories for the shells and for some of the utilities. So just as I was mentioning yesterday, you can write scripts that you use yourself in the shell and in other purposes on the computer. Your configuration as a user is all script related. So every time you go into the shell, or the terminal window, it runs the script, and the script sets all of the resources and things available, gets the environment variables, configures your shell for you. So I don't recommend playing around with it unless you know what you're doing. Otherwise you lose your shell access. But You can modify it like I have done to strip out stuff I don't need. I don't use the history. I take that stuff out of there. Why keep track of all that stuff? Modify the environment, customize it, make it more friendly. Actually, I changed the font on it, made it a little bit bigger so I can show some stuff to you. I made it 80 by 60 resolution. So PS1 equals, well, this is going to include the history number. It's a command. This is an example command that would be in the particular script. And this actually is a modification for the prompt. So you can set the prompt. You can set how much history to hold. You can set all sorts of different variables in the script that loads prior to the shell loading. And every time the shell loads, the script loads. And going back to the concept of scripting, every time the user logs in, the login script loads. Every time the user logs out, the logout script runs. Most of the activities that the user is doing is all script related. So we also have this concept of aliases, and this is what I was saying before. When I typed in C shell, I have a couple of aliases set in certain shells, not on this computer though, or on a different one. And I was kind of testing it out actually, kind of see if those aliases are set on this one. No. So I should probably take all those aliases, put them in a script, copy it on this computer, run the script. In fact, when I go to the shell, you run the script, and the script has all of the aliases in it, so when your shell environment understands all these commands that nobody else has. What you're doing is you're customizing the shell to create some commands that you like to use. As an example on the bottom, LL. So what is LL? Well, that's LS minus LG, or 1G. No, that's LG. So, or LH, or L, whatever kind of parameters that you like to run in terms of the command. But isn't it easier to just type in LL list? Or for me, C shell, because I don't like CSH. So I like C shell, that way I know for exactly which shell I'm going into. So an alias is a definition of new commands by using a string substitute. The format goes into the alias space new command space the other commands. So you take commands and you're changing them. Kind of can get you in trouble. However, there's a couple of guys out there on the internet, you might be able to find it. It was very popular for a while. Took and created a script that made aliases for Linux and Unix to equal DOS. So those people who are familiar with Windows and DOS and go to a DOS prompt and type in dir and all those other DOS commands you're familiar with, takes your C shell and turns it into a DOS shell. But it's a wrapper because it's aliases that are created via the script when you log in that takes your shell and makes it into a DOS environment for you. It doesn't really make it into a DOS environment, it just changes all the commands to DOS naming instead of Unix naming. Makes it easier for people to transition, I should say. So it's probably still out there on the internet. I haven't looked at it in years. I was playing around with it at one point, and then I discovered, well, that's no sense. How can I teach a Unix class when they're using DOS commands? Like, that should not encourage that behavior. So anyway, but some people who fight with Unix and don't like Unix but love DOS, which I'm kind of the opposite with, they want to type in, dir, not ls. So let's change the ls to dir, and we're perfect. We're fine. Okay. So here's some more examples of redefining commands. And redefining commands is okay. It's not something bad, as I'm kind of alluding to, but it comes in handy with this. If you always run mv with -i next to it, move is what mv is, or who with who, and you wanted to date who with a date or something associated, you can combine commands, put it into one command, or you can take a command that's got a whole list of parameters and switches to it and put it all into one word or something. So it makes your life easier in terms of redefining commands. And argument substitution is also kind of interesting as well. So the first argument of the new command, all of the arguments of the new command, you've got the caret symbol, which is the, on my computer, it's on the number 6 key, number key, the asterisk, the number 8 here. So the alias wid, so who grep with a bunch of other stuff. What does that do? Well, when you run the command, you can say wid Igor. So it's the same as saying who fgrep Igor. So you can create this elaborate kind of, this isn't really that elaborate, but you can create a more elaborate and use substitution. So that when you run the command, The command actually, substitutes in values for things that are in the script. I don't want to call it a script, but it's really a command that you're running. So it allows you to sort of create automated scripted commands. So on the command line, when you type in the command, the Igor is substituted in for this information here, which is one word. It's just one first argument. You could take all arguments and substitute them in as well. So another way of automating it. You can check your aliases by typing. In fact, that's probably what I should have done, then I would have known I didn't have C shell on there. But you can type in the word alias, and this is all of the current aliases that are set. Alias HD, to check the HD alias to see if that's there. These are just booleans. It comes back true or false. Yes, no. Unalias, take it away, cancel it. /ls, use the original meaning of ls. So, you created an alias, you called it ls, and then all of a sudden you decide, I don't want to use the real, I want to use the real one, so you can still get back and use the real one. So, bash aliases, how this is implemented, and the way this lecture goes is I'm showing you the generic stuff that's current, and then going back and comparing it with different shells. So, this is what's available in the C shell, in most shells these days. Bash aliases are a little bit different. Bash alias works the same way as the command line as in C shell, but defining an alias in the script that loads the C shell is a little bit different. So what's the difference? You're saying alias name equals a value instead of saying alias space the value space the original command. So the syntax is a little bit different between how you're going to put it in, because the script itself that loads the shell is a slightly different format than the script that loads the C shell. So you have some slight variations. The end result is the same. The syntax for typing in the alias is a bit different in a bash environment. In terms of defining an alias, these are some examples. These are bullets on the slide set. They're not part of the syntax. So type in. I actually had a student yesterday point out, and I didn't realize that. And I've used the lecture for several different classes, and the first time I realized, oh, there's bullets in some of these lectures. So I have to go through and edit this stuff out. But interesting. I had never really thought about it before, but you guys are looking at something in PowerPoint with bullets. And I'm like, and these are commands. And you're like, oh, there's no minus sign in that. There's no dot in these commands either. So kind of weird, actually. You have to kind of think of it like a student instead of a teacher, I guess. Or I don't know. It's kind of weird. Anyway, so aliases that require multiple commands and arguments are defined as functions. So I believe we looked at the concept of creating a function in Perl and creating a function in scripting late yesterday. Maybe you were asleep at the time. But you can also create functions in your shell environment as well. And this is an example of script, and the script has got a bunch of stuff in there. And you might see, $1. Well, that's an argument. So you substitute the argument when you run script. So you say script space. What is this looking for? Well, you could just type in whatever it is you want to type in to run it. Or here's a CS. Change the directory to this, and then ls. This is an obvious, so you can go CS space, whatever directory you're interested in looking at. And it'll change the directory of that directory into an ls command, and give you the results. This is equivalent to what DOS people, Windows people, call batch files. Most people who are diehard DOS people who work in a DOS prompt from the old days before Windows showed up, created myscript.bat. BAT short for batch, and batch is a poor man's excuse for a script on a Windows system. So the more sophisticated script is on a Linux system, but it's the equivalent. Actually we had startup scripts in Windows as well, and we still do actually. We have autoexec.bat and config.sys, which is again the Windows version of the scripting automation that occurs for startup in a Windows, in a Linux or Unix environment. Not to keep putting down Windows, it is by far the easiest operating system. To say something positive about it, you don't have to know anything about computers to use Windows. most people who try to venture out into Linux and Unix, you know, they get a little overwhelmed with the not so simplified version. So Windows is for dummies, is how I like to say it. So but hey, my grandmother uses Windows, and you know what? She's 90-something years old, and she can still use a computer and check email. So that's a bonus for Windows. But computer science people, if you haven't discovered it already, you want to get off of Unix, get off of Windows eventually. Transfer over to something a little bit more sophisticated if you really want to use your skills and you really want to develop and write languages and actually use a system a little bit more robust for the environment. So it's not a bad idea to experiment. In fact, that's why people like MacBooks, actually, because it's a combination of Windows and Linux all in one. So you get both, the best of both worlds on a Mac environment. So no more sales pitch. I'm done with that. Okay, so but I had to say something positive about Windows because I've been bashing it all weekend. But this is a Unix class, so I should bash Windows in a Unix class. Job control. Move commands between the foreground and the background. Suspend commands. Each background job has a process ID, a PID associated with it. We saw that yesterday with processes and creating processes with process IDs. If we type in PS, we see those process IDs and job numbers. In fact, that's where this word jobs comes from, and now I'm sort of curious to see if it's supported on my system. If I figure out how to... Oops, I can't figure out how to transfer over. Okay, next time I'm out there, I'll do a DOS. I'll do a jobs. It won't work. I'm trying to flip over to that screen, but my touchpad is a little bit too it's not sensitive enough. All right, so if you type in jobs at a terminal prompt, it'll bring up a list of jobs. Jobs control is kind of different than processes. It allows you to suspend jobs, and jobs could be in a batch of processes. You can have more than one process per job. Most Linux implementations and most shells will show it out as one job per process, and people use the word jobs interchangeably these days. But in the old days, it meant more like a batch control of processes. Slightly different meaning in today's computing environment. Here's some examples. Spell glossary is glossary.out, ampersand, which meant run glossary.out, and .out in a Linux environment is an executable file, by the way, and put it in the background. So then we have process number 1 or job number 1 with process ID. This is the process ID, and then we add a date to it, put it in the back. This ampersand says put the job in the background, and then we have number 2, and then number 2 finished, and now we have do this one. Now this is the new number 2. So the job batches are replaced by new processes as the new processes are there it is, are added to the system. I'm sort of curious here. Nope, jobs is supported, but I don't have any jobs started on here. But if I did like an ls ampersand, put it in the background, well, it's going to put the output to the foreground, but you can see up here I have one with the process ID. I have to redirect the output if I don't want it to show up on the foreground, but that's another interesting thing you get with, and you see I'm actually I don't have a prompt yet. There we go, now I have a prompt because I pressed return on my foreground, which the background job finished, and the background job that was running was Alias, and you can see that now that job is done. So a lot of system administrators look to see, well, what's running? Because if you remember at the beginning of the lecture when I was flipping back and forth between all these different shells, there we go. We have people who log in remotely. They open up shells, they start batch jobs, and then they disconnect. When you disconnect from a terminal program, you really haven't disconnected. It depends on the terminal program. Most of your terminal emulators and programs these days will disconnect automatically. Because what ends up happening is you log into the system, you start a bunch of jobs, and then you leave. And those jobs are still running on the system. But you haven't been there in a couple of days, but the jobs are still running on the system. Your session is still open. The system doesn't reboot every night. The system stays open 24 hours a day, 7 days a week. So an administrator comes in and says, well, this job's still running. Well, this job was started 2 weeks ago. This user's no longer even connected. Kill the job, kill that job, kill this job, kill that shell. Each one of the shells you create when you're logged in remotely is creating a job. It's creating a process for each one of the shells. Take that, compound it by 200 or 300 users, and put it in every single day, and you log in multiple times. You can essentially create an overhead of processing on the system that's really unnecessary. So part of the system admin job is to sort of see who's connected, who's not connected, write some scripts that will cancel your work, which is usually what's going on these days. If you disconnect, everything's gone. Everything will go away for you, hopefully. Because what you could do, in the old days you were able to do this actually, is connect to a server and start some stuff and then log out and then come in later, check the status of the stuff, redirect everything to files and stuff so you can sort of see how things went. Stuff ran while you were gone, which is what system admins actually do. They set background processes to run, and the background process is going to like back up the system, I don't know, duplicate files, check the ports to make sure there's nobody who's unauthorized who's trying to sniff in, port sniffers and stuff like that. So here's jobs. So the command, if I had jobs running, and if I typed in jobs, I'd see number 1, number 2, the status. It's running. What command is running? So other messages you could stopped, input, done. My system uses done as a status indicator if the message is over with. So let's go back to the foreground to background, background to foreground. We know how to put things in the background already. We use that ampersand symbol, which is above the 7 key on my keyboard. We can say foreground, FG space the job number, which is why we want the job number. And then we could take something from the background and bring it to the foreground, because then we can kind of see what's going on with it. If you put something in the background, if you're going to put it in the background, you're going to redirect the I/O so it doesn't go to the foreground. If you write a script that does a backup or something, you might want to check on it so you can get to it by bringing it to the foreground and then putting it back in the background when you're done looking at it. Because what if the thing's going to run for a couple hours? You want to sit there and watch it for a couple hours. Put it back in the background. Get rid of it so you can work on other stuff. Well, I guess you could always leave it open in a window, which is a lot of people do that actually. Open up a terminal window, run the job, and then go back and look at it occasionally, see how it's doing. Just leave it in the foreground in that window, but open up another window. Because foreground and background processes don't get the same priority. So the bonus to putting it in the background is that everybody in the foreground has a higher priority. So if it's in the middle of the workday, and you have, and this actually happens a lot, you have a receptionist who's sitting there logged into the same computer that you're backing up the entire network with, and she's not going to be able to do anything on that computer. If your backup's running in the foreground, they take up way too many resources. So you stick it in the background. So it goes at a lower priority automatically. And other people can still do the work. Does it really matter how long the backup takes? It can run for days. Who cares? But it still has to run. But in the meantime, you want the system to be usable. So you can kind of shift things back and forth, depending upon the logic. So Control-Z suspends a job and then puts it into the background. So, you're working at the help desk and you're the system administrator for the Unix system, and you get people, hey, the network is running so slow right now. And oh, that's because I'm backing it up. Oh, so you can be nice and hit Control-Z, suspend the background, suspend the process, put it in the background, and then oh, thank you. Users call back up. You go, hey, now I can access the system. So, actually, I noticed that people at ITU should do that more often. Certain times of the day, I can't upload anything. I can't even get connected because I know they're doing something on the network. And they're not doing it fairly because they're doing it in the foreground. They're not doing it in the background. It's not running overnight either, because who wants to work overnight? But the thing is, you don't have to. You start it, you go home, you go to lunch. It doesn't irritate the rest of the people who are working on the network. So, but who knows what's going on in that case? And probably a backup, or they're probably taking image files and uploading it to the EMS or something, or who knows what they're doing. But at certain times of the day, you can definitely tell the bandwidth changes. So the internet connectivity definitely adjusts. As a user, if you're a system administrator and you're running a perfect company environment, users should notice that stuff. Users should have a seamless, not affected by stuff that's going on from a system administrator perspective. In a big corporation, if you were working in the IT department, you were the system administrator, and every single day at a certain time something happened, you'd probably lose your job after a few weeks. Because the big CEO would come into your office and say, hey, what's going on here? How come we don't have consistent? Why are we affected by your backups? Why are we affected by these huge print jobs? They get picky about everything. We want perfect 24-hour day, 7-day-a-week access. Well, there's ways of doing it. to make it perfect. So it depends on the environment, actually. Nobody's on the network, who cares? So a lot of people just wait and do stuff at night, do stuff at, off hours, so. But these are built-in commands, the purpose of mentioning this, that orchestrate, make the user experience better. If we really didn't care about that, none of these commands would actually make any sense to us anyway. We wouldn't have to put anything in the background, move things. So you can pause jobs, suspend jobs, start jobs, resume jobs, and orchestrate that. In terms of stopping, we can actually kill stuff. In fact, a good system administrator who senses that a user has logged in and hasn't been there for a long time, but is running something that's very memory intensive, has like maybe it's a PeopleSoft environment, and they've got, huge thing going on, and it's really causing a bottleneck for everybody else. But they're nowhere to be found. They're not even currently active on the system. Kill the job. So, because maybe the job's a runaway job. Maybe the job is not even like something that, maybe, and they didn't kill it themselves. So usually a system administrator has privileges over all of the process control of all of the users. So hopefully that's the case. And that's one of the things of being the admin and having admin supervisor privileges. You can go in and kill everybody else's job. As a user, you can't do that. As a user, you only have control over your jobs and your processing. They can. Most smart people would set up a script that runs like every couple of checks for stuff, and then the script runs, automatically kills anything that's not active. Because in fact, if you're running a web server, you're running a company and you're hosting web accounts, that happens all the time. Because people, users do all sorts of different things to start doing stuff, uploading huge files and stuff like that. So system admin will set a script that will automatically detect it. Because what are they? They're going to sit there all day looking at this stuff. They'll run a script on it that will go in and kill it. If it hasn't been active in such and such time, the script will time it, just sense the timeout and get rid of it. And clean up the mess too, actually. In fact, most of your web accounts, if you've got an ISP and you have a website out there, and you accidentally deleted something, call them up. Usually there's either a real time or there is a daily backup that is performed on that directory. And you still have it. Even though you removed it, you still have it. Because one of the things that you're supposed to do is back everything up. So if your server does go down, you just buy a new server and you restore the backup, and within a couple hours your users are back and they don't even notice what happened, which happens all the time actually. Or you get moved from one server to another server, no problem. 5 minutes from now you're back up and running, because while you were sitting here on your original server, they restored the backup on the new server, and then they just switched your routing over, so your address was now routed to a different domain, and so within seconds we're back. We're back up. Because you kept that information. All this stuff gets done in the background. It's all done through scripts, actually. So. Changing the state. So state changes, the C shell prints a message at the next prompt when the state of a job changes. So you can use notify to make the shell report the change immediately. Usually something, intrusion detection, I don't know, something fails, you can get notified. Actually, more sophisticated systems these days take the notified messages from the jobs and send emails and stuff out to people. Say, hey, or text messages and all sorts of different things right now to notify people who are supposed to be paying attention to this stuff. So then we also have short forms for commands that we can type in. Example, this is tilde sign. This is the Latin tilde. I don't know if any type of other languages use this symbol. For your home directory. So tilde name is the home directory of name. Tilde AD. So you can use it to do CP a copy command, idea.txt to my home directory. So it's a shortcut. Or ls my home directory add teach. So Filename Completion also exists. You can set the file EC, which is switching it on in terms of the Filename Completion feature, to say cat, which is is going to print out to the screen, trig, or actually no, actually don't, let me not lead you wrong on that command. Cat space tr trig 1a with a space escape. It's going to essentially fill it in for you. So what you're going to end up having here is the ability to type in part of the command and it auto-completes for you. It's kind of like the autocomplete feature of Windows, actually. There's actually undelete, believe it or not, on Unix if you set it correctly, because you can set a history on the inodes, and you can actually undelete stuff as well. So going back to Windows, Control D for help. Sometimes it's the tab key actually that gives you the help feature. Depends on the way configuration is the environment is configured. LSH asterisk is going to show you the help files, the help text, help trig 01, help history. Cat H, it's going to essentially give you out the cat help, so the beep. So anyway, getting to help is just a Control D away or a command away, depending upon how it's configured. We also have the directory stack to deal with. So if you've seen, I used my up and down arrow keys in my shell to get at my history of the commands. All of the directories that you've done is all actually organized through the inodes. And so the inodes keep a history of your traversal through the directory structure. So as you're changing directories here, changing directories there, we can use quick keys to go back through the levels as we're traversing through the directories. So it stores a list of the directories that you are using on the stack and switch between the directories by referring to the stack. And so as an example, I started at the home directory, I went to Advanced Unix, and I went at COPS 104. Let's say that's the name of a class as an example. So we can push the directory onto the stack and do a CD to change the directory. So here we have a pwd, which is a command that shows you your path. My path is home AD. I can use a command called push D. This is the command, this is the prompt symbol. Push onto the directory. We can actually add stuff here. My home directory, teach, advanced Unix, and then I've got this was being pushed on, and actually what you get back is the feedback of the directory that you pushed on onto the directory stack. And then now I can check pwd, and now I know I'm in this directory. So I can check my path. In fact, this is a nice little test to do. One of the assignments has you actually work with directories. So you'll be able to experiment with the command that you're supposed to use. Push D, this directory, push that on, check the path, and I got things pushed on. Changing directories quickly. So we can push the top directory down and do a CD and see what's down. So push D, check the directory to push it down. So it works just like regular old stack, pop and push. Pop and push functions actually work on here. And here's our get the top, push D, pushes the top directory down into a CD. So push D is essentially going to keep pushing us down and down and down and down and checking us out to see what directory we're actually in. And you will have an opportunity to do this, as well as in the first interactive session I showed you the assignments. And for those people who were here, you saw the assignment for grep and find and translate and all of the other commands. And then, in fact, if you missed that, go back, look at the videos or look at the PowerPoints, and you'll see that I'm just like the directory exercise that you'll be doing for this. You'll see the commands actually given to you. So it's no mystery. Thanks. Actually, the assignments really aren't that hard if you have the resources to know where to look for the answers. Here's the pop. So if given that hopefully you're familiar with the stack concept, you push things on, you pop things off, pulls it off of the stack. Pop the top directory and CD to the new top. So we're going to pop D, and when we push it off, now we have a different directory. We're essentially going back down the directory line. So push fills it up, pop takes it down. And when we pop, we are traversing up and down through the directory structure. Other stack commands, dirs lists the directories on the stack. So if we type in dirs, we can actually get the directory number. We can push D to a number, which is not like the normal stack behavior, but if we know we're third in, we can go push D3, and we can get to the directory location that we're looking at that's on the stack. Why do you want to do that? Because you don't want to keep changing the directory. You can tell people who use it a lot when the directory names are so long, nobody in their right mind would type that in. And then, so you put it on the stack, and then you can traverse real easily without actually having to remember that long name that's a couple of lines long for that one directory. And people would like to make long directories. As a side note, are doing that because they want to remember what's in the directory. As an example, if you've got like 5 different builds of a project, you want to know that this one is from this date, this time, this build configuration. So you label, and it's self-identifiable, and you know which one to go to by the information that's listed in the directory, which makes it easier. It's kind of like filing information with really long descriptive file names in terms of Windows files. And for you diehard Windows users, a file in Windows is a directory. It was actually kind of funny. Short, small side tangent here. I ran into an information systems person who had never used anything outside of Windows and didn't realize that directory, there's no such word as directory anymore in Windows. Brand new people who are learning Windows, they call everything files. They go to the file manager and they go into different files. Folders, I'm sorry, folders is what I'm talking about. And files are inside of the folders. So when you say directory to them, they look at you like you're speaking Greek. What's a directory? You know, it's a folder. And there's files in those folders. Oh. And so some of you are sitting here going, I didn't even realize that, probably. The whole terminology has totally shifted over the last several years. Brand new high school kids have no idea what a directory is. It's amazing. Or IT people. I've never heard of the word directory before. Well, they obviously haven't taken a Unix course, but everything is a folder. And then the favorites concept. The bookmark are favorites. So, and all the terminology is kind of changing to be dumbed down, is what I call it, for idiots to be able to understand the system. They dumb it down, change the names, make it easier for grandma to understand, which makes a lot of sense, actually, because then you got more grandmas on the system. So, let's not dumb it down anymore. Actually, tablets dumb it down even further, which is nice. You just have programs. You press on the icon and it runs the program for you. I think that's pretty good, actually. It makes computing a lot more usable. Yeah, as an example, why do we even need another slide tangent, but I'll make this one quick. Why do we even need an operating system these days? I mean, why do we need all these features? File folders and directories and all this stuff. Tablets make your life a lot easier. You press on an icon, you check your email. You get an email in and it shows you the status. And you turn the thing on, it automatically updates for you. You don't have to install anything when you buy a tablet. You don't have to install anything. Or if you install something, you just do it right there. You just press a button. That's dumbing it down. That's making it user-friendly, which is nice. Because unless you're studying computer science, unless you're trying to build these things, why do we need to be overwhelmed with the complexity of that? So I actually kind of suspect within the next couple of years, Windows will turn into a tablet environment. Where you just press stuff, and it does stuff for you. It's kind of like what do they call those things? Devices? Appliances. There we go. So the computer's turning into an appliance. If you had to go use your washing machine or your dishwasher, you just press buttons, and it does stuff for you. So why not have your computer like that? You press a button, and it checks your email. And it goes to a web browser. It gives you your Facebook stuff. And just like your cell phones, our computer should be just like that. So, it's an appliance. But that's weird thinking. And I can say that in a Unix class because this is the complete opposite of that. It didn't start out that way. Unix is definitely not an appliance operating system. It is the exact opposite of it. It's made for navigation, made for utility, made for development work. Appliances, you can't develop on appliances. Unless it's one of the options that are available to you, you can't really do anything with it. So, okay, that's enough of the tangent. Back to the lecture. Push D, pop D. Pop D pops off the directory of a position number. If the number is not 0, then there's no change. If the number is not 0, then there's no change to the present directory. If you have nothing to push on, nothing to pop off, there's no change, there's not anything, you're not really doing anything. So that was the information in terms of the shells and the features that are associated with traversing the directories, the file system, and the inodes in a Linux environment. We also have variables that exist. This is kind of like why I showed you Perl first, actually, because Perl, as you can see from what I gave you yesterday, a lot more capabilities. This is also another scripting environment in terms of a shell capability, the C shell, that supports variables and variable types and stuff, which is similar to Perl. So Perl was based on this, but Perl's got a lot more features, as you're going to see in the next few slides. We have string variables, we have numeric variables, we have special forms of user variables, and then we have shell variables. That's about it, what we're looking at. We don't have the elaborate arrays, we don't have the elaborate hashes, or dictionaries, or databases, or any of the other stuff that you saw in Perl, which is why people like Perl, because you can run Perl in the shell script. You can create Perl scripts instead of shell scripts. It's used as a replacement. You have twice as many features and a lot more programming capability than you do in a shell environment. But if you don't want to learn Perl, don't want to use Perl, and you want to use this all in a shell environment, here's your options for you. Your string variables, set name equals Fred. So it includes spaces in the older C shell, no spaces in newer ones. Echo name, Fred. Easy. So you can actually open up a terminal window right now and say set name is equal to Fred. Depending upon, you can say, you know, my Fred. Depending upon the version of the shell you're using. Come back and say, well, what is it? And then echo is sort of like a printf, you know, from the C days. Fred, set, so set's a list of variables. Unset the name, erases Fred out of there, erases the name out of there. Set env, well, I've shown you print env to print out, which is the opposite of set env. So if I wanted to set the environment variables, it does not change it permanently. If you really want to set your environment variable, you change your login script, sets your environment variables permanently. But what if I'm in there and I say, well, you know, I really want to set it to something else right now. You go set env name Fred, echo name Fred. So now I've added it to the environment instead. Set environment makes the variable visible to any script called from the shell or from the shells containing the set env, which means you can nest up the shells in a hierarchy of shells inside of shells, and all of them are within the same global space. We do have arrays, so we have arrays of string variables. Set colors, it's spelled incorrectly, but we have red, green, blue, and orange. Echo colors, red, green, blue, and orange. Echo colors 3, blue. Echo colors 3, 2, 4. Very, if you were here for the Perl lecture, very Perl-like, actually. So, but Perl came second, so this was the originator. That's a bullet marking, so don't ignore that. Set shapes empty. Echo shapes nothing. Set shape 4, square. Echo shape 4. There we go, square. So the same symbol is used for scalars, the $sign symbol. So, which is very equivalent to, so those people who learned shell scripting from C shell transition into Perl quite easily. Syntax is practically the same, except we have more features in Perl. Braces. So we have using the opening and closing brackets here to distinguish a variable from the surrounding text. Instead of using quotation marks, which is what most people would do in other languages or scripts, so set prefix is equal to Alex. Echo prefix is short for this. So we use the opening and closing braces and to get at the, to distinguish the variable from the surrounding text. So you can also write it like this, prefix out, you know, the opening, closing, ender, which means it's text. You're putting it in quotes. Anything you put in quotes, usually in other languages, it's referred to as the text and not the resolution of what that's supposed to be. It's not a variable. So, numerical variables, you use the @ symbol, which is different than a Perl environment command for variable holding numbers. So @count is equal to 0, or setCount is equal to 0. So the text is differentiated by the variable itself. If we want to call it a number, we use the @ symbol, and we get a number. So we can say count is equal to 5 plus 2. Echo count, we get 7. Treats it as numbers. So it is more type-oriented versus typeless language. Perl is a typeless language. There's no types associated with it. You just do stuff to it and it logically figures it out. So @count is equal to count plus 5, and I think it was like 7 before that. So if we echo count, we get 12 out of that. So we could write @count plus equals 5, which might look familiar to some people, or count plus plus. So it's called C shell because it uses C syntax. So it gives us that ability to write C syntax and use C shorthands in a shell scripting environment, which is why people like it. Which is different from other shells that don't support C as a syntax. Most of the C numerical operators also work, the plus, the minus, the logical, and the and, the ors, and stuff like that. We can have an array of numeric values, just like we had arrays of strings. Where we have set ages is equal to 1, 2, 3, 4, 5, zeros or whatever. Ages 2 is equal to 15, ages 3 is equal to that. Echo out ages, and we get the entire array. So it automatically supports the array concept. These are also dynamically allocated as well, because everything is dynamically allocated, which means you can grow an array as well, which is not mentioned in the slide set, but you can grow it no problem. You just add another item to it, add another item to it. It's not statically bound to an array size like you do get in C. Because C is a compiled language, and C shell scripting is not compiled, it's dynamic. So, in terms of the Bourne shell equivalents, the Bourne shell only has string variables, nothing else. So C shell, if you're going to use it over Bourne, then you've got the advantage of actually having numerical values and types for that. It uses an expression, EXPR, to switch string variables into numbers. So it's almost like casting. So numbers equal to 5 in a Bourne shell environment. We use the expression, the number plus 2, and then the number is equal to 5 over here in C shell. We could just go number plus 2. So this is more C-like. This is more shell-like. So the C shell actually gives you that number conversion instead of having to have everything. Most scripts actually use everything as a string by default. And then if you use it like a number, it treats it like a number. In Bourne, you actually have to tell it that it's a number. So you have to actually explicitly express it like a number in order for it to be used. Special forms of user variables here. And we got the number sign variable returns the number of elements in the variable array, just the same way as it works in Perl. The question mark variable returns 1 if variable is declared, 0 otherwise. Is there a variable out there? You can actually do this to environment variables and see if you have an environment variable set. Because inevitably another job that admins have to do is fix user problems, and user calls you up and says, hey, how come when I type in GCC, it gives me an error message that says bad command or file name or whatever. Actually, that's a Windows error message. Then the admin comes back and says, well, let me check. Do we have your path set correctly? With question mark, with your home path variable, and it goes, oh, that's because you're not mapped to it. Hold on, we'll add it to your environment. And then the user calls back, hey, I can access it now. And you just fix their problem because you changed their login script to give them access to the directory that they didn't have access to before. And you easily check that by using a question mark with the environment variable name to see what the environment was set at. So you don't have to spend a lot of time looking around, you just checked it. Logged in as the user and checked it. Or logged in as the admin and sudoed to the user. So, set the days to Monday, Tuesday, Wednesday, Thursday, Friday. Echo days. We get the 5. Which is the number of days. Check to see if it's there. Yes, it'll return 1 because days is declared. Days does exist. Unset, which is an interesting way of doing it. Unset, because maybe we don't want it set. We want to change the definition of it, or we want to use it for something else. We can unset it. Echo it out. We can say, no, 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 days does not set anymore. It's 0. It doesn't exist. So shell variables. Shell variables can be initialized in 3 different ways. By the shell, by the environment, or by the user with set and setenv. We just saw the set and setenv technique by taking the variable and having it equal to something. The shell can also set it in its shell script when you enter it into the shell. The environment also sets it when the user actually logs into the system. So all of your environment variables are set at login. All of your shell variables are set at the shell script that logs you into the shell, that sets your shell environment. And the user puts it inside of the shell by using setenv to set their own environment. So there's 2 types of shell variables that take on values, or shell variables that act as switches to turn things on and off, which is kind of different. So they have the value of 0 or 1 associated with them if you're switching something on or off. So here's some shell variables that take values, and that's actually kind of like what we've seen so far. We have argument variables that we've seen yesterday, actually. That's an array of command line arguments that come through. 0 is the name of the program. 1, 2, 3 other parameters that follow it. The first argument of the command is 0. The command name is 1. So we can say $1 inside of our script, which is, this is identical to what I showed you yesterday with command line arguments, actually. So also we can say, you know, give me the second argument, give me the third argument. So no upper limit, no feed. So there's no need for a shift on this at all. Actually, it just adds it sort of to sort of like a stack structure, but it adds it to the end. So argument asterisk or $asterisk gives you the array of all of the arguments, the wildcard. Just give me all the arguments, one of these arguments, or whatever the user logged in with. Because if the user put in a bunch of arguments in there, then you have to change a few variables. If not, you just don't bother. The user didn't type in any arguments. Okay, so it makes your script run a little faster if you don't have to actually check for anything. And the number of arguments. So generally this is done, most Unix people when they write shell scripts, they check for the number of arguments, make sure it's correct. Why run the script if the script's not going to work right? So then you get those friendly little messages that come back and say, hey, you need to give me the, you know, when you type in CP, you need to give me some more information here. I need to know what to do with this. So here's the correct syntax. Show the user what they're supposed to do. Correct the user by checking the number of arguments. So this is done for error checking in a lot of cases. And then for running the command itself. We have home, we've seen this already, the path name of the user's home directory, path, the array of path names. We can set the environment path to a couple of different directories. This is essentially what affects the user's experience, actually. Because if it's not in their path, it's just like Windows. If it's not in your path, you don't have access to it. So when you type in Java, you're not going to get anything, even though it's installed on your computer. Most people who run Java and realize, oh, I had to set the environment variable to the class path. Otherwise I can't run the compiler, even though it's installed. Happens all the time with Unix because Unix people aren't installing stuff. They're just going to a window, to a terminal prompt and running stuff. And then they realize, I can't run Java when Java is installed for your account, but you're not pathed to it. So status gives you the exit status of the last command. And there's a ton of other ones. I'm not going to go through all of them. It would bore you completely. Shell variables that act as switches. So those are the ones, as an example, that adds its, they act like variables, actually. So to turn on file completion, we've seen this one already. We go file EC, which means turn it on so it automatically completes our commands for us. That's a switch. It returns back 0 or 1. Yes, it got turned on successfully. Is a 1. No, it didn't get turned on. Or no, it's missing. Ignore end of file disables the control D as a log out. No clobber. Stops file overwriting, which is used a lot actually with the directional I/O. This is, you know, don't clobber it. It's just kind of interesting because a lot of these words for things come from like a very grassroots kind of Unix programmer kind of mentality. You know, when you clobber something, you're overwriting it, you're getting rid of it, you know, so don't clobber it. Notify, immediately notify, notifications about the background job process. Actually, you can add nice to this too. Nice makes a process run at a lower priority. So. Automated scripts. So here's some automated scripts I've been talking about so far, but here's your where to find them in the directory structure. So at login, and I didn't actually create an assignment, I don't believe, that had you modify login scripts. And that's not a bad idea, but I think I gave you enough already, so we'll just leave it at that. So I'm not going to add anything, but next time I teach this course, I might actually make an assignment maybe that has you modify login scripts, because a lot of people are afraid to do this. But lo and behold, eventually you will install something on your system, and the instructions will say, modify your login script. And then the computer science person who's been working in technology for years will go, where's the login script? And then you go online and you see everybody else is asking the same question. Where's my login script? How do I modify my login script? Well, that's the interesting thing. It's not consistent among all Linux breeds. There are some consistencies in the commonalities, But sometimes it's located in hidden file directories, sometimes it's only accessible by root, sometimes it's accessible by the user, sometimes it's not. But they're not things that are going to be thrown at you that you're going to see unless you're looking for it. They're usually in a dot or a dot dot, which means it's hidden, which means you're not gonna notice it. Nobody ever notices that they actually have a login script. On the MacBook, you actually have a login script that gets edited all the time if you're installing new software that you're running from the terminal window, if it's running in the background, or if it's doing stuff. And this is actually very similar, although it's a bash. It's a bash version of this, so it's bash RC on a MacBook. But at login, the C shell executes a range of scripts automatically. It's going to be in the etc. directory that's only going to be accessible by a root privilege, actually. That's going to say, from CSH login. This is for the shell login. So on a MacBook, it's going to be bash and not. It's going to be BASHRC instead. You're going to have that dot in front of it, and this is the bullet for the slide. This is there really is a dot in here. So this dot means it's hidden. So when you do an LS, you won't see it. It's not going to show up, which is why you go out to the message boards and everything else. I can't find my login script. You're not going to find it by going in LS everywhere. You got to know where it is to find it, because it's hidden, it's not shown to you. Unless you use the ls to show the hidden files, and you go, oh wow, look at all these files over here I never noticed I actually had. So .login is your home directory. In your home directory, it's going to give you your login for when you've actually logged in. .bash rc is going to give you is going to be also in your home directory. Depending upon the version of Linux you're on, the Ubuntu puts everything in the home directory. Debian, SUSE, some of the other ones put it in the system admin area, and they're by your user, but they're not local to you, which means Ubuntu is meant to be a desktop Linux environment. The breed is for user control, so it's going to put in everything in your home directory. But actually all you have to do is go online and lurk. In fact, when you're doing this and it says after you've installed Perl on your system because you want to program in Perl and you didn't have that on there before, and it says, well, add it to your login script to add the path to the Perl bin directory. And then you go online and you start looking, and it gives you all these bad instructions. Because it says, oh, put it in this file, put it in that file. And you go, I don't have that file. So the key to that is also mention your Linux version when you're doing your Google search. Say Ubuntu space login script, or user login script, or shell login script. And then you get the right information that comes back, because it's different for each Unix version. A lot of commonalities, but it is very specific. So this is the commonality. At logout, it executes this logout script. Well, what is a logout script going to do for you? Close open files, perhaps. Exit jobs that are running in the background, or foreground but not the background, maybe. So you can modify your login script so you can log out and still have stuff running on that computer. So, in fact, this is what people do when they do attacks. If you don't set the logout to actually stop jobs that are running, exit out of the shell, do a bunch of stuff with it, clean up your mess, you can essentially attack a computer by telnetting into it, starting jobs, logging out, starting jobs, logging out, and you can actually just break it down. I mean, you can actually have the server run like a snail, especially if you have this really huge job that's uploading an MP4 file, some DVD, and it's translating it, or it's uploading it, or it's doing something, and the shell logout doesn't clean it up every time you log out. So it's called you can create a denial of service attack easily that way. But most systems will have a logout that stops everything. So unless you're simultaneously connected, you can't create a bot that's going to go and connect, and log out, connect, and hit, take the server down, essentially. And believe it or not, these are actually kind of low-tech ways of creating denial attacks issues for servers. But people do it. Actually, users do it without even knowing about it. They don't do it on purpose. It depends on the system administrator as to how the logout scripts and login scripts are set, as to what they have access to as well. which is kind of interesting. So when a shell script is called, the shell will execute the shell script that's going to be run to set the environment. The shell script itself will also execute whenever a window is created in an X Windows session, which is the equivalent to doing a terminal, clicking on a terminal icon and going to a terminal window from X Windows. Here's an example of what a typical login script might look like. So it's called .login. It's going to set environment to a terminal emulator mode. It's going to erase this, erase that, change things to uppercase, lowercase, maybe change the font size, font characters or something, or the font type, depending upon how sophisticated the system is. And then echo out, this is who is on the machine, we'll see who you're logged in as, perhaps. So on a set, only a set is needed, not a set environment, since the script is executed at the start of every script. So every time you load a script, this is the interesting thing. You write a script and you create a login for your shell. You say run the script in this shell. You have two forms of automation going on. You have the login script for the shell that's open to run the script, and then you have the script. So it's run automatically, which is really cool actually. And you can run from, let's say you're in a bash shell. You create a you create a script that you want to run in a C shell. You tell it at the top of the script, run it in a C shell. You run from the bash shell, you type in the script name, and you've made it executable. Change mod, you made it executable. It opens up a C shell instead of a bash shell. It sets the environment automatically by the script that runs for that shell. And it loads your script and runs your script for you automatically as well. That's the true automation that exists. So it really does a lot for you. And in fact, here, as an example of the C shell script, if you're going to set a C shell script in that case, you can set no clobber on there. Don't overwrite anything. Set the ignore off. Remove. I would actually remove the directional I/O. Take away the output so it doesn't go to the terminal window. Or redirect it. Set the history. Maybe set the history to 0 if you don't really care about it. Set the prompt. Set the path name. Set some aliases that might be used in the script. So, because what ends up happening is a little bit different from the DOS environment. When you go to a DOS window, everything's the same. Every time you go to a DOS window, everything's the same. It's whatever you're used to. When you open up different shells in Unix or Linux, not all the same. It's customized. So you might have aliases set in one environment that you don't have in the other environment, vice versa. So it allows you a lot more customization in terms of what you're doing in terms of automation. Here's an example of the log out script that might be set, echo switch off the air conditioner. Every time I log out at the end of the day, I got a little thing, hey, don't remember to lock the door, switch off the air conditioning. Reminder, meeting tomorrow at 9 or something. And then you can kind of set stuff for yourself if you want to. So script programming, lo and behold. And executing a C shell script, branching, and we will have lunch after this. We're just going to go for another. I'm looking at my clock, and you guys are, some of you just showed up though. You haven't been here since the beginning. So this, I believe, slide set's about 80 or so slides. So I've got about 30 slides left. I'm not going to go everything there ever needed to know about script programming, but this is going to be kind of a brief overview, and we'll have lunch after this. So we're going to go look at executing a C shell script, which we've looked at writing them and the components of them, but we haven't actually looked at executing them, branching, looping, recursion, and interrupt handling, because you guys are all programmers, you're all computer science students. I don't really have to get into the concept of recursion, hopefully. Function that calls a function. Looping or branching, you guys should be familiar, especially with some of these things. So when you execute a C shell script, you put this at the top, very similar to Perl. How does the interpreter know that this is a Perl script? Unless you would put, Perl up here. So here we're saying that this is going to be run in the C shell. We can change the bash if we wanted to, borne, anything we want to. That's the first line of your script that you're going to write. You're going to open up a text editor, Nano or VI or something like that, and you're going to, or if you speak Windows, Notepad, you open this text editor up. You write the code in here, you put this on the top line, So when you run the thing, it's self-identifiable. So you may need to put it in to switch off default initial executions. You have a default shell actually configured on your system. If you have a MacBook, when you log in, you have a default shell. It's the bash shell, which is your default. Which means every time you run a script, unless you specify the shell, it will always run it in that shell, which is part of the automation. Or you can execute the script manually, but if you put this at the top and you said it's a C shell, and you do this and you go bash space script, the script opens up and goes, oh, no, 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 we're not bash, we're C. So inside of the bash, it opens up the C shell. So you're going to use one technique or the other, depending upon how you like to do stuff. So if you don't want to do that, if you put this inside the script, you make the file executable. You change the mode to make it executable. You type the name of the file and it runs it just like an exe command. Just go ahead and run it and opens up the correct shell. Here you're specifying the shell and then you're putting the script inside of the shell. So, or make shell your default shell script, which is kind of ridiculous if you're going to change your default because you have to run a script that runs in something. But if you don't use the shell, it might make sense. Who knows? Branching. In fact, that's what BSD does here. It loads on bash because it uses the bash shell for the startup script. So, which is why, and you can change it, but your operating system is going to load it. It's going to load bash whether you like it or not, because it needs that for your login and for all your information on a MacBook. So that was everything you ever wanted to know about writing scripts. So, branching. If then, file test expressions and switch. For those people who like C, you're going to love this. It's very similar. So here we go. Here's the formats. If something expression, then a condition, end if. Okay. If an expression, then a command, else, 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 else if, end if. So, if an expression, else if, else. Else is the default catch-all. Else if is the, no, let's see, what about another condition? So I'm going to kind of go through this kind of quickly because you guys should all have some programming language experience in something at this point. And this is boring, but it's just showing you how it's compared to what you already know. So you can't if else one. Here's a script here that's using this. Here's our script. It's going to set the class depending upon the argument value that's being sent to the on the command line. So we're going to go here 1. So set the number. It's going to be argument number 1, which is this guy right here. And then if the number is 0, then class is 0. Else if the number is 1, do this. If it's 2, do that. If it's 3, do this. If it's 4, do that. That way we can kind of run a command and select from different alternatives, styles of running the command once we run it. So you can say, if it's Monday, if it's Tuesday, if it's Wednesday, if it's Thursday, do this. So the script runs every day of the week, but it does something different each one of the days. In terms of the usage, due to this line that was at the beginning, the script can be executed from borne or bash command because it's going to run the C shell for you automatically. So the number 55 is in class number 1. So we can also do file test expressions. This occurs in the expression part of the if-then and other of control statements. So the -d file is the file a directory? Is the file a file? Does the file exist? Because outside of the concept of Windows, it treats files are just files. File, and this I mentioned this yesterday, but inevitably it's a source of confusion for everybody. On Unix, everything is a file. USB device is a file. Your CD-ROM drive device is a file. Your Hello World is a file. Hello World.txt is a file. Everything's a file. In Windows, a file is only a file that's stored on your hard drive. Your C drive itself is not a file. Your CD-ROM drive is not a file. The concept of the device is not a file. But in Linux, everything's a file. So you might want to check, what is this file? So we have command checks in here to test expressions to figure out, is this file a driver? Is it a device? Is it a real file? Is it an I/O port? So what is this thing? So we can run the test here. And then is the file readable? Is the file writable? Is the file executable? Other switches that we can do on here. And those are called test expressions. So we do a test expression because why would you want to open a file that wasn't a text file? and you were looking for a text file to open, and then you realize, oh, this file, that's a LCD display. Oh, okay, well, I can't open up that thing. There's nothing there. Or if we do open it up, what's on the text display? You know. Switch, just like C++. Switch with a string variable, and then case this pattern, case that pattern, case that pattern, default with breaks in there. Break SW, break the switch, break the switch. So the syntax is slightly different. The command structure is the same. So switch, yes, argument 1 is yes. Here's the little script. This is the output of the script, or the usage of the script. That deals with, actually I think this continues. Yes, it does. It deals with a switch statement. So it gives you an example. Looping. And as I mentioned before, Perl came after C shell, C scripting, C came first. So naturally that's where it got this from. We don't have a for each in C, which is interesting, but we do have it in C shell, and we do have it in Perl, and we have the while. Why? Actually, some earlier versions of C do support for each, by the way, actually. You're not going to get it in, I don't believe it's part of Visual Studio, the current C++. But don't quote me on that, but I have a strange feeling it doesn't exist. But Pascal used the for each. Earlier versions of C actually had for each. Basic has for each. There's a lot of languages that do support it. Perl supports it. The format here is for each with a loop index and then an argument list. Most of your scripting languages will use a for each, because why bother having to create a loop? You know, a for loop when you can just do a for each, which is the for each's equivalent to it. You could write your own for each if your language didn't support it, actually, and run it as a function or something. So here we have a for each, and the for each, here it is. Here's the syntax for it. For I, ls, run the ls command. Set the new name to equal to echo I. Basically, you're going in, you're going to rename all these files in something. Kind of dangerous. The text in I that matches anything is changed from this to this. So this is kind of like a reformatting of something, or changing the name of something to everything. Kind of a dangerous thing to do, actually, this particular for each. Here's another example, for each A, B, and C. When you have a list of items, usually with search results, for each one of these things, see which one of these also contains this, or something would be a nice thing. Here's another one that takes some arguments, puts it in the buffer, counts it all up, and then for each of them. Very dangerous as well, because it's changing buffered information, it's rewriting out stuff, changing stuff permanently. So I don't recommend copying and pasting and using these scripts. Checking them out, because they're going to do some stuff and permanently change files in your system that you might not necessarily desire. While is just like C. While, some expression, do a command, and there's no do while, there's just a while. So here we have an example that's going to do a while. Index is smaller than or equal to some limit number, then do something inside. Sum is going to be a plus equal index, index plus plus. These are treated as numbers because they have using that @ symbol next to them. So. Recursion is also supported in the shell script environment. So the script here is C++ C that visits every directory below one supplied by its argument. So it starts at a starting directory and renames all the files ending with C++ to .c. That would be handy. Just start with the root drive and change every single file on your computer or on your hard drive from C++ to C. Here's the usage of it. Foo C++ to foo C is an example of what's going to happen. The usage is C++, from starting at the directory code. So it could be implemented with find. Find all the files in your system that are C++ and change them all to C. I don't have to tell you, it's kind of a very dangerous kind of thing. It's kind of like find all the files on your system and delete them. Like, oh, I don't necessarily think that would be appropriate. So, and it's using recursion because it's for each one it's going through, and then down here's the recursive call file. It's actually calling itself. So, and file is the file here for each file, call file. So it goes and finds a file and renames it. Goes and finds another file, renames it. Goes and finds another file, rename it. In fact, that's where the -r comes in terms of, delete this directory. -r. which means recursion, which means goes through recursively and delete everything in here, which means it applies the same command to every subdirectory that's in there, which is the keyword recursion, although it makes some people shiver a little bit because they're afraid of it. It's used as it's a nice word, actually. It's used in Linux all the time when you delete everything all in one shot, -R, gets rid of everything. Pulling apart a file name that has an extension on it. So here's a foo.bar. Set the variable to foo.bar, and basically name without an extension, and then just the extension. So you can go var.r, var.e:/r to get the information out of it, which it comes in handy as well, because maybe you don't know the file extension on something, but you want to find the file, so you just want the first part of it. You want the extension, or you want the name without the extension. So a standard shape. Most of the recursive scripts have a shape, which is kind of like a pattern associated with their design. And here it is here, where it's kind of like patterns in C or C++. We have a base case and then we have a recursive case. So if you design in C or C++, if you design a recursive function, you're going to have the function end eventually, which is kind of the same concept that you're going to use with C shells, where you have a base case and then you have an alternative case that's going to happen, that's going to give you that recursive behavior. Otherwise, what ends up happening is you get runaway scripts that just run forever, which is kind of like an endless loop. I'm not going to take your computer down, but it might do some undesirable things on your computer. So for files in a directory, do something to the file, else, if not, end, so you can exit out of there. So title words in web files. And here's an example of a wtitle script that examines an HTML file in a directory below one supplied by the argument. And if the output, it outputs, this should be it, not if, outputs the title words on each one of the web pages. So nice little script. Goes through, opens up all of the HTML files on your entire computer, let's say, for example, and returns the tag that says title on it, because everybody in the header usually puts the title of the web page on there, so you can identify it from a web browser. And it'll say my home page in this particular example. It sees title, it says my home page. So returns all the information that's relevant. And so here we can use a recursive function for that, because we have to go through every one of the HTML pages to return the title that comes out of it. There's some other ideas for you, and this section is called notes on the top only because, these are examples. And one of the assignments is going to have you use grep, actually. So grep -I title file gets the title tag name, awk -f. You're going to have to use awk in a couple of your assignments as well. Separates the line using this and prints out the second part here. This is my home page, which is the title. So awk -f with another example. Separates the line using the symbol and prints out the first line. So my home page. This is actually the better, more cleaner looking example, I would believe. So there's your just command line switches with utilities like awk and grep that I went over in the first interactive session. So go back and look at those lectures if you're interested in those commands. And you'll have to use them in a couple of the assignments to do some automated stuff. Here's a little bit of usage with give it a directory name, find the wtitle. What did the bus just let out or something? Everybody's just showing up now. I'm actually going to end in a few minutes. So Michael Kane, picture Kane. So sorted and duplicates are removed. In this particular case down here. Use sort and use unique. So this particular example is kind of useful to note that you wrote a script. The script used something recursively inside of it to go find something out of a title. We applied other Unix commands to it, in this particular case sort and unique, to say in the commands output that we're getting, sort it in ascending order, or remove the duplicates or something. So we can do a word count, we could do a sort, a search. Any sort of Unix command can be added to the script when it's run on the command line. These examples. So last but not least, exception handling. And this is interrupt handling, not exception handling, but not as good as in the Bourne script. Not as good as in the Bourne environment. C shell does support some of it. Only interrupt is supported on a C shell. The control flow is hard to understand, a little bit hard to work with. Much improved with TC shell, which is why that one is used. It's an upgraded version. TCSH, this shell here, is an upgraded version from the C shell. In the beginning of the slide, I said most people who have C shell aren't really getting C shell, they're getting this version of it. It's the same, it's just an improved version of it with more commands and more control for interrupt handling and other things as well. So the format is on this interrupt label, do something. And so the script must have a line that says label. This is sort of like the go-to statement in BASIC from the old days. We had label. In fact, you can still do this in C. You can go to labels in a program and handle. But what do we get in operating systems? As if you remember yesterday and the weekend before, we have interrupts. So we have signals and interrupts and system calls and stuff. So if we really want to pay attention to interrupts, we can create our own interrupt handler. And, actually, from a programming language perspective, we actually have traps, software level interrupts that exist. And so traps and interrupts are actually held the same way, or handled the same way. So we can kind of see if we sent, for example, a call to the CD-ROM drive to open, or the DVD drive. We have a script that goes to the DVD drive, opens it up, takes the DVD movie, loads it up into MPlayer, and translates it, sends the audio out through this port over here, sends the video to the TV set, does all this stuff, aka you've got a digital box here, a music box, Linux box. And then the CD drive won't open, or there's no CD in the drive. Well, you would use an interrupt handler because CD drive's going to come back with an interrupt. It's, hey, there's something in here. How do you want me to proceed? So you catch it, create a handler, you catch it, you go out, you send a message off to the user without bothering to do anything else. Please insert CD, or please insert DVD. Okay, so in basic form. So here's an example here on an interrupt close, and then we have close out here. Echo close the end of the program. User close the program. So on an interrupt, no CD down here. Hey, dummy, put a CD in the drive if you want to play it. Or give me a file to open first if you want me to open a file. So in the end, practice writing scripts in different shells is how you learn what each shell actually entails and what each shell what is required for each one of the shells. So unless you've actually experimented with it, which is the purpose of all those 6 assignments, is to have you experiment with different shell script commands, with different commands in general. Because until you actually use it, you don't actually know what you're talking about. And you can't listen to me and actually learn it. You actually have to implement it yourself. So you will figure out what environments support a subset of the commands from the others. And then you usually find a shell you like. And after you've done that, then set that one as your default shell. If you're brand new, the bash shell is not bad, actually. I wouldn't switch over to the C shell, because bash shell does a lot of automated stuff. It's really nice, actually. It sets a lot of environment variables for you. It has some built-in features that are good. Bourne is still a default for most of your Linux distributions outside of BSD. So, on that note, it is time for lunch. So let me stop this video so people watching it don't have to listen to our lunch plans.